Hello, hello, and welcome to our monthly Amsterdam Ruby Meetup. I hope everyone is settled in with some snacks and drinks. I hear myself in an echo. All right, I'm going to continue. My name is Ton de Bruin, and I'm one of the Amsterdam Ruby organizers. With me is...
Hi, I'm Rayta, also one of the organizers. Welcome. And we're not the only one organizing the monthly Ruby meetup, though. We have a team.
Arno. I don't hear
Yay! So our team of organizers. I think our slide deck is stuck. Oi! So, well, anyway, we have a nice Ruby team. So the rest of our team consists of Floor and Arno. Arno is our tech lead and audiovisual expert. He will be doing the technical part of the meetup tonight, and so you can expect some music in the break. And we have Floor Drees, a senior program manager at Microsoft and organizer of a gazillion other meetups and conferences. So you may have seen her at other meetups as well. So join the chat. Tom, you want to tell the audience something about how they can join the conversation?
Yes, I'm going to talk through this echo for me. Yes, so let everyone know that you're watching today. We're using the AMSRB hashtag on Twitter. Yes, I see the nice banner. Please get involved in the chat in our Slack. You can join by the link that is on screen right now. Please join the Amsterdam channel to chat about this meetup. Ask your questions and all that later, and we will relay the questions to the speakers when we are in the Q&A.
Yep, and so we also have a code of conduct. And please be aware of that and read it. If you haven't already, it's down here, the link to the code of conduct. Basically, it boils down to be kind to each other and respect that everybody's here to learn and to share. And if you do notice something or anything unsavory, please contact any of the organizers through Slack DM or Twitter DM or via the means stated in the code of conduct. Yay, slides! Okay. So now we have this cool thing, right? We need the next slide because we're going to show the cool thing. Yes. Coming up in partnership with Overzen. Look, do you like plants? But I'm going to do this commercial thingy right now, right? Do you like plants? But do you forget watering them? Like Tom? Yeah, well then you should come and build our self-watering plant. So that's the 3rd of June at 6 o'clock with a maximum of 20 people. We're gonna build a self-watering plant system.
Yes, you will need some development experience in this to get to participate in this session. So do make sure you have a Mac or PC with a free USB port to hook up an Arduino board and have the Arduino IDE installed ahead of time. To get all set up for this event, we will send you a package with a bunch of stuff like an Arduino board, a plant seed, so you don't even need to choose which plant you're going to plant, and then everything else will also be there, like a t-shirt, some fun swag, and even a snack and a drink, so you don't have to, like you can all set up in one box.
Yeah, and then the 3rd of June, we'll all jump onto a Zoom call, and in 2 hours, you'll build your own watering system. So this event is a great place to connect with fellow developers and like-minded tech fans. So
Yes.
sign up quickly, because again, we only have 20 spots. Check the Meetup page for more details. And remember that people signing up have to reside in the Netherlands, because we are shipping these things to you.
Yes, and shipping costs outside of the Netherlands are a lot. So for the program tonight, we have we've invited two inspiring speakers. We will kick off first with a talk about fiber-based concurrency in MRI from Wander Hillen. And the second talk will be about virtual machines, specifically Vagrant by Sophia. And after every talk, we will have about a 10-minute Q&A session. And we will also have a short break, about, say, 15 minutes between the talks.
Yep. So let's get ready for our first talk. Wander Hillen. He's a freelance software developer. He's a runner and a former military officer. And in this talk, Wander will cover a few methods to allow for preemptive scheduling of fibers in MRI Ruby. His talk, Fibers from the Inside, is a continuation of last Meetup's talk by Julik about Ruby's new fiber scheduler, concurrency, fibers, and you. So, Wander, over to you.
Yeah. Hello, everyone. My name is Wander Hillen, and I'm here to talk to you about fibers in Ruby. So what I'm going to talk about today is actually like three things. First, I'm going to go over like what Julik talked about last month, just for the people that couldn't attend or didn't find the time to watch the restream. Next, we'll talk a little bit about the fiber scheduler interface that is new in Ruby 3.0. And finally, I will talk a little bit about auto-yielding fibers, which is something that kind of fills up the final bit of the fiber concurrency story in Ruby as I see it. And finally, we'll go a little bit into the future, and we'll see what is actually in store for like future Rubyists like us. So a little bit. Never mind. I thought there was an about me slide, but it's not. That's fine. My name is Wander. I've done a lot of talks on the Ruby Meetup already. I used to work for the military, as Rayta said, but I have found a new calling in writing beautiful software, and Ruby is very nice for that. I used to work for WeTransfer in Amsterdam for a long while. At the moment, I'm a freelancer, and currently I'm working for Lendahand, a crowdfunding platform for social impact. It's a fun place to work, and they're always looking for more people, so check them out if you're looking for new work. And with that, let's go for the actual content of the talk. So what Julik talked about last month. So this is a little bit of a quick introduction. If you are completely out of your depth here, then I would advise you to, after this talk, go back to the previous one. But in Ruby, there are basically three ways of doing concurrency, or doing more than one thing at a time, because these things mix concurrency and parallelism at the same time, and we have processes, threads, and fibers. Processes share nothing. They are completely scheduled by the operating system, and as such, they can be very parallel, but because they don't share anything, any object in memory that you could maybe share will be invisible to each process. So each process has to keep its own copy, and that results in a lot of memory space being used up. So the next level down is doing threads, and you get into a multi-threaded program where multiple threads can share the same memory space. So, for example, if you are running a Rails application, then you only have to load all your classes once. All your threads can share those, and you don't have to sort of duplicate all those objects in memory. So that saves quite a lot of memory, though not as much as you could save by using Fiverr, because a thread still has its own space in the operating system. It's still scheduled by the operating system. And in Ruby, you give up a little bit of parallelism by going to threads instead of processes. Although, as Jule talked about last month, there are certain things like I/O that can be done in parallel. And finally, we come to fibers. Fibers are what's known as coroutines, and they live on the same operating system thread. So that's also where the name comes from, because many fibers make up one thread. They are not parallel at all, and they have to share their time on that operating system thread manually. That has to be done by the programmer. But what they do gain is, because it's not a thread, they can all share that same operating system thread, and by that they can also share, for example, the stack space used by that. And this makes them very, very efficient. That is nice because you can fit way more concurrent connections. For example, if you have something like a website that you're hosting, if you use threads or processes, you will very quickly run into the limits of how much one server can supply. But maybe it runs out of memory way sooner than it will run out of processing time, for example. Fibers are kind of a way around it, because they are so memory efficient. You can fit way more connections into one. But of course, because they are not parallel, we come to what I call the fiber sweet spot, which is doing nothing. And this is amazing. Computers are super good at doing nothing, like people, by the way. And this is because waiting for things is really time efficient. You can wait for an infinite amount of things at the same time. I can bake a cake and wait for the dishwasher and wait for the laundry machine. I can do all those things at the same time. And if I had more machines, I could wait for even more at the same time, right? Of course, when they're all done at the same time, that's a problem. But if you're a little bit careful about it, you can wait for a lot of things at the same time. And most web apps are actually super full of waiting. So you wait for a request to come in. They don't all come at the same time, and come just once in a while. Hopefully you have a very busy website and you have a lot. But still, they won't come in one big batch. You'll have them one at a time. And maybe you have a very simple website that just returns files, but often you will have to do some database calls or caching calls. And you have to wait for the database to compute your return. When you finally have your response, then of course you need to send it to the user, and maybe this is a user with a very slow internet connection. So even your very lightweight React app that's only 5 megabytes will take a long time to be sent. And that's more waiting. And in all that time that it's waiting, your computer can do a lot, because waiting for database call might only take 10 milliseconds or something, which you might think is not a lot of time, but for computers, you can do so much in 10 milliseconds. You could accept a whole bunch of new requests or handle other stuff. And this is really what fibers excel in. Now, they do have big downsides, and basically the biggest downside is that the programmer has to manage when they switch between fibers. And this is pretty tricky, as we'll see, but we'll come to that later in the talk, because this downside is basically what the talk is Fibers also cannot migrate between threads. They are really pinned to that one thread. So, and that leads us to the third downside. Like if you block a single fiber on the thread, then none of the other fibers can run because, as we talked about, they are not very parallel. They are not parallel at all, in fact. So if you have one fiber that is just sitting there doing nothing, or maybe it's doing a lot of things, but it's not giving away its time to other fibers, then none of the other fibers on the thread can run. So you might have potentially thousands of fibers waiting on this single fiber that's just not giving back its allocation. And this is kind of a big deal. And all the problems with fibers come from this third problem. And it's also like fibers have been in Ruby for a very long time, almost 10 years. And around them have been a couple of very nice frameworks. So you have Event Machine. They don't seem to have a logo. You also have Celluloid. A little bit more modern is Async, which has the best logo. It's literally Async with a Ruby in it. Anyway. But the problem is that you need to structure your entire application around this framework instead of structuring it around something else that wants to be structured around, like Rails. And usually when you have that kind of conflict, Rails tends to win, and then you have a problem because you need to really write your program around the use of fibers to get the biggest benefits. The biggest problems is the normal code, like it will not call fiber.yield. Input-output, as we discussed, will very often block to databases, to upstream APIs, even sending responses to users. And even when you move around that, then big computations can also block, because if you just have a very busy, like a while loop computing something, and it takes 10 seconds, then in those 10 seconds it will typically not go yield. And so any other fibers that could run will not run because already this big computation is running. Yeah, and that's kind of tricky. And because in any gem you pull in, there might be such a big computation, you're pretty much housed, because you either need to use all the async or fiber specific gems, and if there's not any of those, but a really good non-async gem, you still can't use it. Because it will probably do stuff that's not compatible with your fibers. So, yeah, this makes fibers pretty unwieldy to use in production. In Ruby 3.0, it was released last Christmas. There was a super cool new development, which is the fiber scheduler. It basically does exactly what it means. It schedules fibers. Now, what does this mean? It means that if you have one defined for your current thread, there's a method like fiber.setScheduler, then every standard library method will call yield instead of block. And this is actually an insanely big deal for fibers, because let's see how this is implemented in all the write and all the read methods, like wherever they are, like even if they're off in some gem, they will be monkey patched, because everything in Ruby always comes down to these few things that are just implemented by the Ruby virtual machine. So what we're looking here is a piece of code from MRI for that Ruby will call if it wants to read from a connection, from network connection typically, but there are no bytes available. Then it will return, I have no data for you, and Ruby will then call RB IO wait readable to basically wait until it's readable. It's pretty straightforward in its naming. And And the change in Ruby 3.0 is these first 5 lines, where it starts with value scheduler and including the if block. And what you see there, like it says, if the scheduler is not qnil, qnil is the C equivalent of what we call just nil Ruby code, then it will do RB scheduler IO readable and return. And of course, if the scheduler was qnil, then this if will not be executed, and the rest of the function will go as normal. But this RB scheduler IO readable is where all the magic hides. So what is that all about then? Yeah, so the scheduler receives the fiber and it stores it somewhere inside itself. And then it may use any number of ways to determine when to resume this fiber again. So, and this is deliberately super vague, like any number of ways or somewhere inside itself. What does this mean? Well, the Ruby team didn't really have a clear idea of how this should look. So they were like, well, let's have all our gem writers come up with clever ideas. And for Ruby 3.1, we'll choose one of them to be the default. But right now, there's not a default, but anyone can write their own scheduler and use that or use any other scheduler in their code. The scheduler only of the standard library will only declare how it should behave or what methods it should provide. So, for example, if you want to be waiting for input-output, it could use EPOL on Linux or KQ if you're on some BSD variant or macOS. It could use the I/O control ports on Windows. If you're trying to block on a timeout, basically you do sleep flat 1000, for example, to wait a second. That is also a blocking operation, and so it goes to the scheduler. It says, I want to sleep for a second, and the scheduler says, cool, why don't you go sit over there, Mr. Fiber, and in about a second, I will call resume on you so that you can resume after that second as if nothing happened, and in that second, all the other fibers that have told the scheduler that they want to be run can have their time in the sun. This is, by the way, an incredible area of data structures. If you like data structures, then this timeout section is where you want to be. They have heaps, they have timer wheels, they have all sorts of fancy big notation under the sun. Just a FYI, if you're interested, I am very interested. Then that is the place where you want to look, and there's a lot of good work to be done there. But as we mentioned, there are actually more ways than just sleeping and input-output for a fiber to block. If you have a big computation, then it's not necessarily blocking, but it's certainly not yielding to other fibers. And I was looking at this Ruby 3.0 release release announcement, and I saw this fiber scheduler, and so this is insanely cool. But there's still the big computation problem. So I was like, there has to be a good way, right? So, and then I thought, like, this is Ruby. Can I just monkey patch the if statement or the while statement, and or maybe even just send? Like, can I monkey patch function calls and make my own? So I went off and I looked at the code, and it turns out that you can, or well, not really the if statement, but you can definitely override function calls or method calls. So my first idea was to do something that Erlang popularized. Is basically you keep a counter of how many methods have been called, and like every fiber gets, let's say, 1000 method calls, and once it's out of method calls, then it will always call you to give other fibers some time. In Ruby, there is something called the tracepoint API. Has been available since like Ruby 1 point something. It's been there forever. And there's a ton of events that you can hook into. It was originally meant for writing profiling tools, but you can also use it for this. So my first experiment took like 3 minutes to write. It was really quick. And it used this API, but that wasn't really a bit sad. It did work. It did work. But the code slowed down by 5 times, so it was not really worth it. And I was looking at why does this happen? And the problem there was that this tracepoint API itself was mostly made in Ruby. So for every Ruby method call you did, you would add 2 or 3 other method calls. And that, yeah, the overhead was just insane. Luckily, there's also a C equivalent in MRI at least. And that's called RB add event hook. It basically does what it says, it adds event hooks. And you can use that in much the same way. And that was also pretty nice, but you know, even I really tried optimizing this, but I couldn't get it to be more efficient than like 2 times slowdown. So yeah, 2 times slowdown is a lot of performance to give up, especially with Ruby being all about I'm going to be 3 times faster than Ruby 2. So I was like, it's probably not a good idea. Now, of course, this tracepoint API, as I mentioned, was originally meant for writing profiling tools. And there are basically 2 ways of profiling. The first one is the tracepoint way, is that you hook into everything. But you can also do sampling profiling, where you ask the operating system to interrupt your program every once in a while. And when it does that, you quickly look, what was I doing? And the idea is that over longer periods of time, you will get, on average, a representative sample of what your program is doing. So at the time, I was working on the Haskell compiler. And there I learned about how they do it, is you can ask the operating system to send you a signal, in Linux at least, to send you a signal in a certain number of milliseconds. And then you just install a signal handler that will call a fiber.yield for us. So for example, if you say like, well, I want any fiber that runs for longer than 50 milliseconds to automatically yield, you need to say, hey, in 50 milliseconds, please send me a signal, and you install a signal handler that will forcibly yield this fiber for you. And this is actually, it sounds very dangerous, but it's safe because the Ruby virtual machine will only handle signals when it comes to a point where it's safe to do so for the Ruby internal. So it will never disrupt your Ruby code. And as an extra bonus, you can have a separate subclass of fiber that implements this behavior when calling resume and when calling yield. And you can leave your normal fibers alone. So if you know which of your fibers might block on big computations, then you can have those be auto yielding, and you can leave all the other ones on the normal behavior. And this was actually pretty nice. The overhead was only 4%, and I think it has a lot of benefits. Although there are still a lot of downsides as well, right? So the signal method is a little bit shaky. It is, I've only made it for Linux. It might work on other platforms as well, but I'm not sure if it will ever be like a general solution. Of course, since it relies on MRI behavior, it's probably also an MRI only solution, although if that is a big problem in practice, the C extensions are not guaranteed to handle signals in a sensible way, and they can do an arbitrary amount of work before they return to the point where the Ruby VM can handle the signal. So if you have a lot of big computations in your C extensions, then this might not work. And finally is the problem that if you just have too much work for one thread, then since fibers cannot migrate between threads, like what you would want to do is called work stealing, is where a thread that is idle can actually take fibers from a thread that is really busy doing a lot of work. But yeah, that's not currently implemented, although I was talking to Samuel Williams, the author of the async framework, and he mentions that, oh, this should be doable in like a week, and I was like, oh my god, I thought this would be like a year of work, but he was quite optimistic, so who knows. Yeah, so the fiber future is pretty bright, I think, especially with this new fiber scheduler interface. And I think that is because so much of Ruby workloads are in the area of web apps, and web apps do a lot of I/O and usually not that much actual computations. You can already see this in Rails 6.1 or 6.2. There will be something called load async for active record models, where if you want to do multiple database queries, you can tell them to do like, user.all.load async, and Rails will farm that query off to a separate thread pool. But why a thread pool? This is actually basically the dream case for fibers. Is you want to do a little bit of work, some process somewhere else, in this case the database, is doing all the actual computation, and all you have to do is wait. This is exactly why I want fibers instead of threads. So I expect future versions of Rails to at least make fiber-based solutions possible for that. Background workers is another case. Like, even though they're called workers, a lot of background workers that I've seen don't actually work all that much. They're mostly background waiters, right? So at my current job, we have several Sidekick clusters just for mailers. And that's fine. I mean, mail is an important workload, but most of what they do is waiting for the mail provider to say, it's okay, we sent your mail. And this is also like, you could get way more concurrency with a fiber-based background worker. There aren't any good ones yet, but I think with the fiber scheduler improvements, we'll see a few in the near future. And finally, what I think will push fibers further in the future is just further improvements to the Ruby itself. Like I mentioned, work stealing should be possible. There's no technical reason that it can't be done, except that it needs more work in MRI. And in future Ruby versions, there will be a default scheduler. So all this magic behavior that I've been talking about for the last 26 minutes will be available, but you don't even have to define your scheduler anymore, because it will be there by default. Well, I hope I haven't left you like this lopsided, or maybe I have, in which case you might have questions. So I'm here, and if you have questions now, then put them in Slack or ask them to the organizing team in any other way you know. And if you don't have any questions now, but have any questions later, still put them in the Slack because I'm there pretty often and can answer them then.
Yes.
Thank you. Thank you, Wander. So we have a couple of questions here. Let's start. Tom, you want to kick off with the first question?
Yeah, we were wondering, having researched fibers in this way, have you been able to use fibers in your own app so far? How did this help with the new?
I'm currently a freelancer for another company, so my own app is a little bit shaky, and I really don't want to be the guy that comes somewhere like, what you should do. You should rewrite everything in a fiber-based library because those people are worse than others. It's terrible.
Okay, so what prompted you to?
The quick answer is I've definitely played a lot with different fiber libraries. Back at WeTransfer, we wrote one of the main sort of download streaming servers. We did a lot of experiments into rewriting those into like either crystal or into fiber-based approaches. But I haven't worked there for 1.5 years now, so I don't know how that project ended. At my current company, no, I haven't done anything with fibers. But like I said, we do have a lot of workloads that would really benefit from the fibers, like the mailers. So Timo, if you're listening. Yeah. Okay. Any more questions?
Yeah, so we have another question from David. How would you decide when a fiber should yield? Is it only on blocking operations?
Yeah, this is a very good question. It really depends on the workload, and I know this is the worst answer ever because it's always true. But like certainly on blocking operations, but not only on blocking operations. Like if you know that your fiber is going to block because it goes sleep or IO wait readable or wait writable or something like that, yeah, then you should always yield. And just let the scheduler say, like, if the scheduler has nothing better to do, then it will just return to your fiber anyway. If you have, for example, a big computation, like I wrote a blog post as well. And there I used a big Fibonacci computation, but you can imagine that you have just some computation that's really intensive that will take some time. And let's say it takes 10 seconds, right? And in this case, like maybe you think 10 seconds is too long because I want to at least sort of handle incoming connections within half a second. Then you can either in the loop itself, you can say like, if I have this many spins through a while loop, yield and let the fiber come back from the scheduler when it's time again. Or you can use something like the interrupt-based method that I talked about in the talk. If you have if it's some method in a gem that you can't really control. But it's definitely not only on blocking operations in the traditional sense, it can also be blocking because it's just working for a long time and being irresponsible.
Yep, thank you. Tom, you have another question?
Yes, so we're talking about fibers and it's all new things in Ruby 3 as well. So in your opinion, do you think this is what Ruby is moving towards, using more fibers also internally in things, or what do you think the future for fibers holds?
Well, actually, I think programming in general is going to move towards like evented loops with but basically fibers and work stealing to handle like large concurrent operations. So you can see that in a lot of other languages as well. And I think this is a really good way for modern applications, that mostly network applications, to work in on modern machines. Like back in the day, like when we were young, the CPUs weren't quite as fast, and the networks weren't quite as omnipresent as they are now. But basically, all the the big let's say language frameworks that you see in you see that are up and coming. Like you have Go, evented loops with work stealing. You see Crystal is moving that way. You see that in the Beam, in Elixir and Erlang, even Nginx is going that way, and that's like C code. So I think it's really a good way. Like if Ruby is gonna sort of evolve and remain relevant as the big web language, or at least the biggest dynamic language in web backend, then I think this is a really good way to sort of keep up and improve the possibilities of the language itself.
Right.
Cool,
Does
thank
that
you.
make sense?
Well, it sounds like you're a pretty great fan of fibers. So
Fibers are great.
so basically, so once we can go to dinner parties again and birthday parties, and once we're allowed to, what's the elevator pitch for fibers? Like, what do I tell them? Like, why should they? Like my mom, for instance. No, I'm joking. Like, what's the elevator pitch for using fibers? Or like basically, what prompted you to look into fibers? Did you have like a specific use case? Like, okay, like this thing is killing me. I need fibers for this, so I'll dive into.
I just thought it was very cool tech. But if I had to sell it to someone, I would go for like the oldest and I think best selling proposition there was and always will be is you get more for less. Right?
More for
It's
less.
like you get more throughput for the same amount of CPUs and the same amount of server space that you have to buy. So in a business context, I think unless you're really doing CPU heavy stuff, then they're not a good fit. But in a place where they do fit, and as I mentioned, I think a lot of, for example, Rails apps are an extremely good fit. Then they can really shine and they're much better than what we have now.
Thank you. And I think we have time for one last question. You have another question, Tom?
Maybe. I do see with someone more. Would you have any other code examples that you want to share from your explorations into Fiberland?
Yes, I do, but I will post a link to my blog in the Slack, if that's okay.
Yes.
Because I don't, it's difficult to present the code in the, just by speaking about it.
All right, then we'll wait for it in Slack.
Okay.
Okay. Well, thank you very much for your time and your amazing talk, Wander. Definitely catch up in our Slack. I think the community is loving your talk, and maybe there are a couple of questions there that we missed. So feel free to look them up. And I think we're ready for a break, right, Tom?
Yes, we are. And this time there's music, so you know when we're going live and when we are.
Yeah, I hope it's not too loud. We'll be back in 15 minutes or so, around 8-ish. See you then.
See you then. Hello, everyone. Welcome back from our little break. Hope everyone got a new glass of drink of choice. Before we get started, let's talk about speakers. Arno, slide. I can add it myself. Yes, hello. So before we get started, we're planning the next couple of meetups ahead. So for the next couple of months, and we're looking for speakers. So let us know if you're up for that, and send us a Twitter DM or send us an email or find us on Slack if you know who we are, find our faces in the member list, and send us a little description of your talk, a title, like a 2-3 sentence summary, and then we can plan you in for the next couple of events.
Yes, thank you, Tom. So let's get ready for our second talk. Big welcome to Sophia. Sophia is a software engineer at HashiCorp. Hi, Sophia. And she's working on the Vagrant project. She previously worked for Anaconda Inc., Moo, and Hootsuite. And today she will talk about building Vagrant with Vagrant. Sophia, take it away.
I'm muted, turns out. Okay, I can start from the beginning. Can you hear me now? Okay, so thanks again for the introduction. I'm Sophia. Today I have a little talk prepared about building Vagrant with Vagrant and the challenges that go along with building Ruby applications and distributing them to users on the desktop. So a little bit about me. I'm Sophia. I'm a software engineer on the Vagrant team. I've been in open source for a few years in Ruby and in Python. So a little bit about Vagrant before we get started. For people who aren't familiar, Vagrant is a Ruby desktop application that is used to manage virtual machines in the CLI. We're going to talk a little bit about how we go ahead and package Vagrant and our challenges there. If you're interested in checking out our GitHub about like how we do like this process, you can find it at hashicorp/vagrant-installers. So Ruby is pretty awesome with like their gem thing they have going on. You just like gem build and you have this artifact that's just like installable or runnable anywhere you have a Ruby interpreter. So this is like super awesome if you have like control over where this application is running. But say you are going to give this gem to someone to run on their desktop, then maybe you might run into a bit of troubles. Like the user has to then know which Ruby to run against. Maybe there are dependencies in your application, like there are with Vagrant, and you need to like have different versions of some softwares available. And this becomes like a big process for users to be running the project, but also for developers to like do stuff like recreate issues. So the question is, how do I get a Ruby application to be easy installable and running consistently across many different machines? So answering this question really provides value to the end user, so they don't need to know a lot about how to run the project that they're trying to run. And it also helps us developers so that we can recreate issues and actually solve bugs instead of just trying to track down if there is some like incompatibility between different versions of Ruby's in our application. So the answer that we have is to package up Vagrant. So ship it with Ruby and all of its dependencies, and that way we can control the environment that Vagrant actually runs in. So we do this process using Vagrant. So before we get into that, for the uninitiated, let's talk a little bit about how Vagrant works. So the Vagrant file is like the configuration unit for like running any Vagrant project. So this tells you like what your project should actually look like. We have a Vagrant box, and this is basically like the machine image that like gets brought up when you run like a Vagrant up. And then we also allow you to have provisioners. So here you can define things to run against your target machine once it's brought up. So now that we're all experts in Vagrant, we can go ahead and build some installers using Vagrant. So the first step in this process is to make sure we have like reproducible builds. So we use Packer to do this. We create some VMware machines with it. We install all of the build tools we need, and then we use the Vagrant post-processor to spit out our Vagrant boxes. So in our Vagrant file, we can say that the box we want to use is the one we generated using our Packer process. And then the next thing to do is to write a script that actually goes ahead and builds our installers. And we can ask Vagrant to be able to run this script against our target machine whenever we bring it up using a provisioner. Okay, so now that we have our Vagrant file kind of set up so that the process of building our installers should be pretty streamlined, we need to actually do the thing where we like figure out how to build the package. So in Vagrant, we have 3 steps that we follow. The first is building the substrate, and then that's like all of the packages that Vagrant relies on. Then we build actual Vagrant, so that's doing like the gem build step. And then we need to generate an installable package. So that's like the step where we have a thing that a user can install. So the substrate layer, as I mentioned, is all of the dependencies that Vagrant needs. So that's like building out Ruby and its dependencies, and curl and some of the other stuff that Vagrant relies on. We're like a little bit cautious about when we change this layer of our package. We're like looking out for stuff like if any of the dependencies have CVEs or something, or if between versions behavior changes, then we need to be like really cognizant of those things whenever we're changing this substrate layer. So the package layer is where we do the step where we build our gem and then install it into our substrate. And then this is also where we do that last step where we generate out the package. So this generating of the package is different per each system that we're running on. So on Mac, we'll use like package build and DMG build or such in order to like get out like a DMG and then do the whole like notarizing bit after that. So once we have our Vagrant file ready, that will drive our process. We have our script that actually goes and creates our installers broken up into those steps. Then all we need to do is be able to run the script using Vagrant. So we do this using like a provision. So if we have a matrix of boxes, which represent the targets of like installers that we want to build against, plus we have some place to run this in CI, plus a little bit of magic, then we end up with all of the installers we need for all of the application or all of the targets we run on. And then if we peek inside this package a little bit, we can see we have like the binary Vagrant, so that's where like, the user uses or sees. And then we have this embedded directory that has all of the required like dependencies, so that has like Ruby and curl. And then we also have this gems directory, and that's where like the Vagrant gem lives and all of its dependencies. So I have a little bit of a demo where we can go and build a Vagrant package. If I can share my screen. Cool. So here we have our matrix of boxes. It they're all commented out because we don't want to sit here all day building a bunch of installers. Instead, we're just going to build this one Ubuntu installer. My Vagrant machine is already up. And I actually already have the substrate built. And I did that just because it takes a long time to do that. So all we need to do then is go ahead and provision this Vagrant machine to do the packaging step. So here it goes off. It's just updating. And if we give it a little bit of a second, it's going to find the substrate that exists locally that I already built before this. And then it's going to go ahead and build that Ruby gem and install it, and then build a deb package. So if we look up here, we see that this Vagrant gem has been created. We see that it's getting installed into the substrate. And then we see that it's actually created this deb. So we can go into this VM, and we see that the deb exists right here, and we can install it. And there we have it. Cool. That was it. And share my screen back again. Cool. So that was it. If you are interested in Vagrant, you can check us out at HashiCorp/Vagrant. And if you're interested to learn more about the installers, we're also on GitHub there at HashiCorp/Vagrant installers. Thanks for hanging out, and I hope you enjoyed the talk.
Hello, we're back. Thank you for the talk.
Awesome. So we have a couple of questions for you. Would you like to start with the first one, Tom?
Yes, just so that I understand it correctly, you're using Vagrant to set up a lot of different virtual machines, different OSs, and then creating gems for every different OS available.
Yeah, so we're building like whole installers. So for each different OS, we have to like package in there.
You dropped out for a second. All right. No, but that's cool. We do a similar thing at where I work, and that works very well. We're also using Vagrant for that, so yay.
So we have another question. We package almost everything for Debian because it gives us unattended upgrades, and that solves the majorities of CVEs. So does Vagrant allow for unattended upgrades, or which steps need to be taken when there are vulnerabilities reported to any of the dependencies?
So when we go ahead and build like out Vagrant installers, we go in and like manually like update the CVEs. So that's like whenever we have a release, which is like every like couple of months maybe, we just make sure everything is up to date. There are no CVEs logged against anything like in that substrate layer.
Thank you. So I don't see any other questions in Slack. Do you have any other questions, Tom? Maybe some I missed?
Yeah, no, I wonder, like, do you have any other tools similar to Vagrant, or tools you work on that you're like, these are cool tools, I want other people to know about them?
At the moment, no, but
No. I saw Visual Studio Code. Are you happy with that?
Yeah, I mean, it does the things that I like. I like that it has the terminal integrated. Honestly, that's the only thing that I really like. It's amazing. Yeah, it's cool.
Okay, cool. Well, thank you. Thank you very much for your talk, Sophia. Well, actually, I have a lot of generic questions, but just as like questions I'm very curious about and I'd like to know. So, for in the Ruby community, is there anyone in the Ruby community that inspires you? Like, who is your role model?
Oh, I don't know. This is a hard one.
All of them.
Yeah, all of them. Like everyone who's ever answered any of my questions on GitHub. Wow, I love them.
Well, thank you very much for your time, Sophia, and your talk.
Yeah, thanks for having me.
I think we are at the end of our Amsterdam Ruby meetup.
Yes.
Yeah. So our next meetup will be on the 15th of June, and we hope to see you there. So there's a big question mark there. So because we're still also looking for speakers. And I want to give a really big shout out to our tech person and DJ, Arno, and our moderator slash social media expert slash mom of chickens and Finn, Floor.
Yes. And I guess we've reached the end of the meetup then. From the entire Amsterdam.rb team, we hope you enjoyed it. If you have any other questions for our speakers, they are still on Slack. Please ask your questions there and they will answer them. We hope to see you next time.
We have to wave awkwardly.
Yes, until Arno.
Till he decides to switch us off, Arno. Arno.
Arno.
Arno.